Good morning to everyone. I am Chandrakala, Department of Silkworm, University of Agriculture Sciences, Bangalore. Here, I had carried out my PhD research on genetics of white muscardine disease resistance in thermotolerant bivoltine Silkworm bombyx mori. As a part of my PhD program, here I am presenting the performance of 6 generations of crosses between muscardine resident thermotolerant bivoltine breeds and muscardine susceptible productive bivoltine breed of Silkworm bombyx mori. Coming to the introduction, as you all know that the Silkworm bombyx mori, it is a very important and economically resinous insect, and it is and vulnerable to or sensitive to many pathogens and biotic and abiotic factors, and mainly in biotic factors, the disease like white muscardine, it is very common in India and it is predominantly in rainy and winter seasons. Regarding this, in this study, the objective I had taken this in this study is phenotypic assessment of selected silkworm breeds and their generations, and also the genetics of muscardine resistance needs to be studied by generation mean analysis. Here, the muscardine resistant thermotolerant bivoltine breeds like B1, B4, B8 identified from the previous studies were crossed with the muscardine susceptible bivoltine breed, that is CSR4, to raise the F1, F2, BC1 and BC2 generations were obtained crossing with F1s with tolerant parent and that is susceptible parent respectively. Here you see the B1, B4, and B8 are the thermotolerant and resistant to muscardine infection, whereas CSR4 is the productive but susceptible to the muscardine infection. From these genotypes, we raise the 6 generations like parent 1, parent 2, F1, F2, BC1, and BC2 were reared at once, and these the parent 1, parent 2, F1 are the non-segregating generations, whereas F2, BC1, BC2 are the segregating generations. Here, in each the non-segregating generations, you took 3 replications. In each replication, we maintained 30 worms. For non-segregating generations, 1 brood taken each generation, and half of the brood was maintained in the normal conditions and half of the brood is maintained in the muscardine inoculation conditions. And these breeds and their hybrids and their generations were inoculated with the fungus load of 9.04 into 10 to the power of spores per ml, and yet the 0.5 ml per silkworm was done immediately after the 4th molt and before resuming the feed in the 5th instar. Here you see in the figure the Bevaria bassiana, that is white muscardine growth in the Sabrodus maltose agar and the dextrose agar medium. Here in figure 2 showing that the general rearing under muscardine inoculated conditions, the symptoms of worms, here you can see that the oily specks on the worms and dead worms and white mycelial growth on the silkworms and vomiting of the silkworms. Here you can see. This is under the muscardine inoculated condition. Coming to the next, that is in figure 3, here we studied that the performance of parents and crosses for ERR. ERR means that is effective rate of rearing. The effective rate of rearing, it is a quantitative character that indicates the survival ability in the larval stage. The formula for effective rate of rearing is number of cocoons harvested. Here you see the number of cocoons harvested by the total number of worms taken during the rearing into 100. In this figure, you can see that here the y-axis and the x-axis. Y-axis represents the reduction due to the muscardine over control and deviation from mean ERR to muscardine control, that is x-axis represents the baseline at is 0% reduction in ERR and 0% in the deviation from mean ERR. Here you see that the breeds and their crosses occupy the extreme right extreme right of the plot, which indicates that they are resistant to muscardine infection. And also here the breeds and their hybrids occupy the left side of the plot. They showing that they shows that they are susceptible to muscardine infection. Accordingly among the hybrids, that is F1 of B4 into CSR4 and followed by the F1 of B1 into CSR4 are the hybrids where showed the major resistant to the muscardine infection. Among the parents, the before showed the resistant to muscardine infection, but the other breeds and their hybrids showing the susceptible to the muscardine infection. Then the fifth instar, sorry. The fifth instar and cochineal by number and cochineal weight by muscardine inoculated among the six generations of crosses between muscardine resistant thermotolerant bivalent breeds and muscardine susceptible productive bivalent breeds. In this table, we can extract that among the breeds under control condition or normal conditions, here you see the B1 and its crosses F1 B1 into CSR, F2 B1 into CSR4, BC1, that is B1 into CSR4 into B1, and BC to B1 into CSR4 into CSR4 showed the highest larval weight, cochineal by number, cochineal by weight, showed the highest quantitative traits among these six generations. But whereas in muscardine inoculation conditions, the B4 and its crosses, here you can see the B4 and its crosses showed the highest quantitative traits like larval weight, cochineal by number, and cochineal by weight.
Okay,
from this study, we concluded that the B4 breed and its crosses can be a potential parent and crosses with resistant to Bavaria infection. Yeah. Anybody? Yes. I thankful to my advisory chairperson, that is Dr. Manjunath Gowda, a professor, Department of Agriculture, and also I thankful to the Department of Science and Technology, Karnataka, for giving an fellowship for my conduct the research program, and also I great thankful to the University of Agriculture Sciences, Bangalore, to provide such an opportunity to participate in this event, and also I great thankful to the Dalhousie given us such opportunity in this platform to present my topic. Thank you.